So, good evening, everyone. I'm Prableen Kukreja, a PhD scholar from IIT Tirupati. So, let's start our session, week 9 of computer networks. Any doubts from the last lecture? Yes, come on. If there are any doubts, please write in the chat box or raise your hand or unmute yourself so that I can know. Last time we have covered socket programming. Please write in the chat who were present in the last lecture or whosoever has seen the YouTube recorded video. Or who has not attended. Please can you tell me so that I can know. Write in the chat or unmute and tell me. Were you present in the last lecture? No responses. Am I audible in the first place? Please make this class an interactive one. It shouldn't be like one way, like I'm only speaking and you guys are listening. Okay. Could you last okay, it's not related to the current class, don't worry. Sudha, were you present in the last class? It was a totally different topic. Okay, it's fine. Uh, it was a totally different topic. We are not going to have socket programming as we have discussed in the last class. The iterative socket programming and the UDP server, TCP client. I'm sharing my YouTube channel name. If you haven't seen that, you can see from these. We have last time covered the programming thing in C language. The socket programming. Today we are going to start a new layer of network layer, though that part is remaining concurrent servers and all. Maybe in the last in the last 5-10 minutes I'll try to cover that part. I'll not go with the programming of the concurrent servers. We have already done the iterative servers programming, each and every part, with the comments and everything we have done in detail. You can see the last lecture if you guys haven't watched it or you were not present in the class. So let's start. With the week 9. Today I'll start with the new network layer. Though some part of this, again I'll say some part of trans socket programming is left. I I want that you should cover it yourself because that's concurrent servers, iterative. Though I'll give a summary at the end of the class about that. So let's start with the network layer. Already we are very behind. So today we'll cover the addressing part and also we'll start with the QoS part, quality of the service. So yes, can someone tell me about the network layer? What are the functionalities or how it is different? What is the main function of functionality of the network layer? Yes, come on class. What are the devices in the network layer? In the first few lectures, we already have discussed the summarized version of the network layer. We know what is network layer. I hope so. You know that you might have heard about the routers. As we discussed in the first class only, in the first week class only, routers, switches, L3 switches. Basically, these come in. I'll say this: these are up to network layer architecture, or these come in network layer. So what is the role of these? Can I say the role is which particular part to follow from source to destination? That is the main part of the network layer. Like if I am in a source address and I want to reach to the destination address, I mean in the how to reach there, that will be indicated by the network layer. That network layer will help me in that. How it will help me in that? With the help of two functionalities which network layer provide, that is addressing as well as routing. Today we'll focus on addressing part. Like, what is addressing? As the name suggests, addressing is you have to identify a particular node. How to identify a particular node? If I have to reach somewhere, I have to reach to the destination. First part is I have to identify. I should know the address, then only I'll reach there. The first part is that. And then I'll do the routing thing, that how to reach there. First, I should know know the address of that, and the second thing is that how to reach that. The second part, this is the secondary part. Now these are the two main functionalities. We'll discuss today the addressing part, and then we'll go to the quality of service and other things. But the first functionality is addressing, which we'll discuss in today's class. And talking about the routing, what does routing says? Or I'll say, what does routing protocol says? Can I say which route to follow? I have many routes from source to destination. And now which route to follow, that will be, or where it should be forwarded to, where the packet should be forwarded to. To which route the packet should be forwarded to, that we'll get to know by the routing things. So if I talk about same as with the, like as it is discussed in the class also. Suppose postal mail address, I have to post somewhere. Suppose you have to post to me only, Prablin Kukreja, CSC Lab 2, Department of CSC. This is my address, suppose. IIT Tirupati, in Tirupati, Andhra Pradesh, India. So first of all, first of all, the post will go to obviously the country, then to the state, I'll say, then to the city, Tirupati, then it will reach to IIT Tirupati, then in IIT Tirupati, it will reach to the department, then the particular lab, and then to me. So I can say there is a proper hierarchy. Can I say that? There is a proper hierarchy which it is following, like how it is going to me, how it is coming to me. Can I say through this a proper route, a proper hierarchy, a proper address is there? There is a hierarchy of addressing scheme as well. So similarly, if I have to send the packet also, I can say that a proper hierarchy of addresses, proper route, it should be available to me. So routing protocol, if I say, that is also a hierarchical way. You have to uniquely identify every host in the network, I can say, which is having a similar principle of postal mail address. And like suppose if I talk about this relating to the network. If I suppose I'm saying www.google.com, so Google machine which is residing in USA, they have to have the access from and you are accessing it from Bombay. So how will you access from Bombay the machine which is in USA? This is all the context of this networking part, how we'll go through this whole network, how the packet is transferred, and all these things. And what should how should routing behave? What do you think? Like how, okay, we got to know that okay, network layer will help me in addressing. The second part is network layer will help me in finding a particular path. What should be that path? There are multiple paths. So is it like uh, which path should I follow? Can someone tell me? Like I have three paths. What can be what which path should I follow? What do you think? Yes, come on. Are you guys understanding? I'm giving the gist of this. I'll come to the addressing part. We'll also solve some numericals as well. I think it's not solved in the class, maybe. So not that much. So I'll solve previous year gate questions as well, so that you can get the clear understanding of that. First of all, we are only discussing about the network layer, the gist of that. So can you tell me which route is the best one? What like leave about this technical words or jargons. Let's stick to, like, if I'm having three paths, what do you think? What will be the path which a person should choose? Let's come to a layman world. Yes, come on. Everyone can hear me. Am I audible? Why today the class is so silent and no one is answering? Am I audible? Can someone write in the chat? Hmm. Okay. So if I'm audible now. Can you tell me, like, what do you think? Okay. Someone has written with less traffic and secure. Okay, nice. Yes, one can think of that. Okay, whichsoever route is having lesser traffic or whichsoever route is more secure. Yes, that can be a metric as well. So, or the other way, I can think of that whichever is the minimum, like less traffic, as you said, less traffic, secure, or one can think which is a minimum path, whichever is the minimum path. But always the minimum path, it is not the only metric. Like minimum path only is not a metric, because there can be a case like I can reach through one very easily, like very fast. But at the other end, that if I push all the packets to the one, it is the lowest, like minimum path, which can make me transfer from source to destination the packets very fast. But at the other end, if I try to push all the packets, I can have the degradation, because it may have low end to end capacity as well. So suppose if I see that one path is like uh, one path is very short, and okay, I thought of, okay, let's transfer this data through this path. But there can be a case that if I push that and it has very low end-to-end capacity, very less capacity, then packet drop or degradation can happen. So as you said, as one of you said, that okay, the other things can be security. Yes, if our application is secure, is demanding security as a prioritizing metric, obviously a path which is more secure that should be considered. And on the other hand, we should also see that the minimum path can also be a metric, but with the minimum path, we should also consider that, okay, that the degradation shouldn't happen. So there can be various metrics as well to consider this routing thing, that we'll discuss in the next class about routing, how we'll do. And one like first thing that also come, I should know what is the minimum path. If I'm saying that, okay, that I can go through the minimum path, but do I have a minimum path? Do I know that this one is basically one will take me to the destination faster than two or three? So first thing is I have to find that minimum path, but I don't have whole topology for that, which means I don't have the whole structure, map structure, topology to find out what is the shortest path. If you might have done in like a data structure course as well, like we can find the shortest path with of a graph or so. If we have a whole topology by Dijkstra's algorithms, Bellman-Ford algorithms, but here we don't have whole topology, because every router here, I'll write here, not there, as I can say that and I can't have the shortest path. I can't run the shortest path algos here because whole topology is not there. So why it is not there? Because yes. Any doubts? Let's proceed. Because every router here is behaving in decentralized way. Or in easy words, I can say I don't have any central coordinator. For that, so that is why I don't know the whole topology. I don't know the shortest path. I can't find out the shortest path from this whole with these standard algorithms. So then I can say it is a huge job to find out what should be the next hop. What should be the next hop to reach the destination, so that it should give me the optimal path. And this is the job of this network routing. This was just the introduction of the network routing as well as the addressing part. Is it clear the functionality? Though we'll go in detail about these addressing and network routing. Is it clear? Please give thumbs up if it's clear, or write in the chat yes. Should I think that it's okay? What about others? Only 2 students are there. Yes, come on. So this was just the introduction of the network layer along with its functionalities introduction, I'll say. Now let's go ahead. Internet architecture. Now coming to, suppose I have one lab 1. This is just what is the same as discussed in the class only. So I have a lab 1, I have a lab 2, and there is a router which is connecting my lab 1 with the lab 2. Suppose this is the way. I'm just saying how the internet architecture, it behaves in hierarchical fashion. Now, so this was the suppose two labs in my CSC network. Now, if I say that, okay, in the organization, how these CSC network labs are connected with each other, they are connected by router. Now, this was my CSC network, and this is suppose EE network. This was my lab 1, CSC lab 1. This is CSC lab 2. IIT Tirupati, suppose. And this is EE lab 1. And this is EE lab 2. Again, the CSC network and EE network, they are connected by router. Or the other department labs also. Suppose civil department or here mechanical department. Now, if I talk about, this is my, the whole universities, basically labs and all, networks and all, and how they are connected. Now coming to, this is suppose IIT Tirupati, and this is suppose IIT Madras. These are the labs here, and these are the labs here. Now, how they are connected? By Ethernet network, by a router. Anyone, can you tell me what is this ERNET network? ERNET, can anyone tell me? Just I'm trying to say how this hierarchical fashion, how they are being connected through hierarchical fashion, like within each group, how they are connected by router, then within an organization, how the labs are connected, then across the organizations, how these are connected. What is this ERNET? Come on.
It is a government program to connect multiple central universities.
Yes. Aman, you were not present in the last class.
Yes.
Have you seen the recorded video?
No, I don't. I'll have
Okay.
to see.
Like last class, we have done the socket programming, and I think most of them like haven't seen in this class as well. So if anyone of, because it's an important topic, we have done programming itself. So if you guys have any doubt, like we can discuss in the next class, or you can mail me or write in the comment in the YouTube channel. So, as you said that ERNET network, it is a government initiative. Basically, it's education and research network, I can say. Government initiative, what is it? Basically, to connect the various institutes. Now again, I can say this is my ERNET network. And this is suppose Airtel network or BSNL or anyone, I can say. And then again, they are connected by a router. So this is basically how I'll say how this internet architecture is internet is basically organized in hierarchical fashion. This is just the main motive to show these all things. Now coming to autonomous system. Yes, what is autonomous systems? Come on. Come on. Yes, class.
The system that operates independently, ma'am.
Systems that operate independently, and someone has written network of groups of routers following common policies. Yes. Or I can say, as we have said, that which are following common policy, which are operating independently, or I can say which are under same administrative control. What do you mean by administrative control if I'm saying that? Can I say it is managed by single organization? Can I say that?
Yes, ma'am.
Now suppose mm, so basically if I talk about the internet architecture, here what how it behaves is like, suppose I have I how I'll not draw the diagram, I'll just like how it behaves is it is taking the services from one end and providing it to the another end. That is how it behaves. And there are some reserved networks as well, like military networks, I'll say. Take the service and but don't provide the service to another. This is just example. These are called the reserved network. What are these ISPs? Now only I have mentioned a line like provide the service. What are these ISPs? Internet service providers. I'll come in detail, don't worry. As the name is suggesting, internet service provider, what do you think? Which are providing internet access, can I say? Internet service provider, which means which are providing the internet access. How they are providing, how they work, they maintain actually the autonomous system. Okay. Net okay, provides internet. Okay, Pushpanjali. Organization like Airtel, BSNL, etc. Yes. So basically, these organizations, these are basically which are providing the internet connectivity to another group of, I can say, ISPs. In other words, these autonomous system which are providing internet access to another group of autonomous system. What do I mean by that? If I talk about the architecture, suppose the students of one organization, suppose I'll talk about IIT Tirupati only, they are getting services from IIT Tirupati Autonomous System. IIT Tirupati Autonomous System is getting service from AirNet India. As we saw that what is AirNet India Autonomous System? Like here only I have written, which is connecting the various institutes. These are basically government. This is a government initiative which is basically providing the internet services. And AirNet India, suppose it is getting the service from Bharti Airtel Autonomous System. So this is whole internet architecture, like how ISP, how the autonomous system is
प्रिया
provided.
क्लास अटेंड करती है क्या? कोई प्रिया नाम की तो है, तनिष्का चंडोलिया भी है कोई.
Please, can you mute yourself? It's a request from my side. Please, if you don't have any doubt, you are like, please don't unmute yourself. Unmute yourself if you have any doubt or if you're answering a question, because it's creating a disturbance in class. So this is how the internet architecture is behaving, like how it is working. So one autonomous system is providing the service to the another autonomous system, and how the whole hierarchy is maintained here. And as we saw, there are some reserve network like military network. It only takes the services and it doesn't provide the service. Clear? Should we proceed? And there can be a pairing between the ISPs as well. What do you mean by pairing between ISPs? We got to know what is ISP. It is an internet service provider which is giving a service. Like the students are getting the service from autonomous IIT Tirupati Autonomous System. They are getting the service from AirNet India. They are getting the service from Bharti Airtel. Whole hierarchy is maintained. Whosoever is providing the service, like these are basically internet service provider. Now, what is this pairing between the internet service provider? Any idea? ISPs, okay, we got to know, as you told, one of you only told that, okay, Bharti, like Airtel, Vodafone and all. Now, what is this pairing? And what is the advantage of that?
Ma'am,
Yes.
peering is nothing but if a user will he will download something from the server cache memory, and that user will become as a server to another user, and like so on. They will share the data which they have taken from the server, from the main server.
Yes, absolutely correct. So, as you have said that they are sharing the data, or I can say it is a process where two ISPs directly exchange data between the networks, data or traffic, I'll say, whatever is there between the networks. That is basically a pairing thing. So two ISPs, they are like sharing their data traffic between them, exchanging the traffic directly, or they can use a third party as well. So what do you think, what can be a benefit? Like, okay, you said it correctly that, okay, they are sharing the data, they are exchanging their traffic. What is the advantage of this pairing? Yes.
The geographical area or the logic area where we can send data increases. Like I can send data to some other SIM holder or internet provider person.
So with the area thing, what can be the benefit to the end user?
So in case of area, it would be like, suppose I want to send some data to somebody in other state or other country in that. And in case of network providers, let's say Airtel and somebody is using BSNL, so like transmit or receive.
Can I say in that case my cost can also be minimal?
Yes.
Can I say the latency can be or the speed can be fast?
Yes, yes, ma'am.
Faster data transfer? Can I say better bandwidth? Can I say? So basically, that is the benefit of this pairing, like getting the services from the other part, or exchange. I can say directly exchanging the traffic. That is basically the pairing part. Now coming to our main topic, that is IP addressing. Till now, we have discussed about the architecture, internet architecture, how the hierarchy is maintained and all. Now coming to the main thing, IP addressing part. Why we need the addressing? Because to identify the network, I can say we have discussed about the postal network, like how this addressing is similar to the postal address also, and how we'll maintain a hierarchical architecture also here. And why we need the addressing? In simple words, I want to identify where I have to send it, where I have to send the packet, or I can say in the technical words, to identify a network as well as host inside the network. Because I can have multiple hosts in one network, so I have to identify that also. So for that, I have to identify the network first and then the host afterwards. So I have a network address, I can say. My whole addressing, basically IP addressing, it's divided into network address as well as then the host address. I have two types of addressing schemes. First, we'll come to the classful addressing. Earlier, we used to do the classful addressing. I'll come to that, why we are not we shifted to classless and all. First of all, let's try to understand what is classful addressing. So we have 5 types of classes: class A, B, C, D, and E. If I talk about the classful addressing, first of all, classful addressing is fixed number of bits for network. Let's say, as I told you, addresses, basically address space. We have the host address and the network address. This is whole 32 bits. And in classful addressing, I'll say there are fixed number of bits for network address and host address in the classful addressing. Now, what are these classes? Let's try to understand it. If I'm writing 0 as a prefix, this is class A. And here, the network, and this is the host address. And this is here 8-bit. This is here. Okay, before this, I should tell you that like 8-bit, 8-bit, this is divided into 4 parts. 8-bit, this is, as I told you, this is 32-bit. 8-bit. And how I have to write it? Suppose the IP address is 203.100.30 dot. Actually dotted. So these are divided by dotted decimal format. And 8-bit integers are here. So this is this 8-bit integer, 8-bit integer, and 8-bit integer. So if 8-bit integers are there, which means maximum I can have 0 to 8 to power 8, which means 0 to 255. 6, 7. What is this? This is binary. Can you convert into decimal? I'm hoping that you know how to convert this binary to decimal. Anyone? Yes, come on. Before going to classes, just I'm trying to understand, making you understand that how we have to write this. This is dotted decimal format. This is basically binary thing, binary part. You guys know how to convert binary to decimal and decimal to binary? 255. If you don't know, then I can help you. I'm only getting one reply. What about others? Yes, come on. Come on, guys. So I'm hoping that everyone knows. Like 2 power 7 plus 2 power 6 plus 2 power 5 plus 2 power 4 plus 2 power 3 plus 2 power 2 plus 2 power 1 plus 2 power 0. This is how we convert it. I'm not going into detail because I'm hoping that you guys should know about this. And so that is why I have written 0 to 255. And again, dot 0 to 255, the range of this, again 0 to 255, and again 0 to 255. This should be the range here. I'm not talking about the specific class, I am talking about overall. Now coming to class A addresses. As I told you, okay, first thing is the prefix is 0, and the second thing is, as we know that in classful addresses, what we have fixed number of, I have written here, the sorry for the disturbance. Okay, as we know that we have the fixed number of host address and the fixed number of network address. Okay, fixed number of bits for network address and the host address. So what about the class A addressing? If I talk about the class A addresses, anyone, can you tell me how many fixed number of bits are for the class A addressing for the network and the host?
First octant is for network and 3 octants for host.
Yes, absolutely correct. And Aman also 8 and 24, absolutely correct. Both are correct. So first octet is for the network and last 3 octets are for the host, or I can say the first 8 bit, they are for the network and the last is for the host. Last 3 octets are for the host. So how many hosts are there and how many network addresses are there? How many hosts are there? How many maximum number of hosts are there? Host 24. How many number of hosts? Absolutely correct, Aman. It's basically 2 power 24. Actually, it's not 2 power 24 also. I'll come to that. It's slightly lesser than 2 power 24. I'll come to that. In short, like approximately, I can say 2 power 24 host. Slightly lesser, I'll come to that. This is class A. In class B, how many number of hosts are there? Now here I have 1 0 here reserved. Oh, sorry, 1 0 here, the prefix. So that, why is this prefix first of all? Can any one of you tell me? Yes, Aman, you are correct. -2 actually. We'll come to that. Why here we are having the prefix?
For class identification.
For the class identification. So, or I can say we are like obviously for the class identification 0. If it's like starting from 0, I'll like directly say we are at the in the class. This is the class A. If it's like 1 and then 0, then it's class B. So whole hierarchy is maintained here. And okay, now what about class B? How many number of hosts are there in class B?
2 power 16.
2 power 16. Absolutely correct. And what about class C?
2 power 8.
2 power 8. Absolutely correct. Now, actually, I was telling you that we have approximately 2 power 24, 2 power 16, 2 power 8. Not exactly, because one is network address and one is broadcast address. Can anyone tell me what is this network address and what is this broadcast address?
In network, the host bits are all zeros, and in broadcast, they are all ones.
Yes.
And
Basically, yes, come on.
uh, network is used to like identify like which particular network we are in, so that after that we can send the host. While for broadcast, it is for sending message to everyone in the network.
So basically, we have here two types of extra addresses. Like that is a network address, as he told that it's basically to identify network, and broadcast address if we have to send the data to all the hosts in the network. So basically, these two are reserved here, the network address as well as the broadcast address. If I talk about network address, as he has told that these are all zeros in the host address part. And these are all ones in the host address. Can you write an example of class A, B, C, the network addresses as well as the host addresses? I'll just come in a minute. I'll take water break and come in just a minute. Till that time, please write class A, B, C, network address and host address. Like one of an example for each of them. Write in one message only because it will be difficult like if you'll write in multiple. I'll just come in 2 minutes. Yes. I was expecting the answers from you. You got the question, everyone? Am I audible?
Yes, ma'am.
You got the question? Anyone? Okay. Can I say simply, what is the range of class A? Can anyone tell me?
0 to 127.
So can I say about the network address? If any network address I have to write, can I say like suppose 125.0.0.0, because these three octets, as you said, that these are reserved for the host address, and if these all are zero, this is a network address for class A. Am I correct? Absolutely correct. Okay, Aman. Aman has written class A 127.0. Okay, let's write what he has written. Class A 127.0.0.0. Absolutely correct. Class B 128.0.0. Okay. How many class B, what are the hosts? Class B, can you tell me, is this correct? Anyone? These two are hosts here. These two octets are host here. Though it's correct, we can write here. It can also be 128 point, I can say here, something like 233.0.0. Am I correct, Aman? This is also network address,
Yes, ma'am.
because here two octets are reserved for class B, and similarly for class C, I can say 192.233.128.0. Yes, absolutely correct, Pushpanjali. 178.12.0.0 class B network address. Absolutely correct. Now, if I talk about broadcast address, the places where we have put zero, I can say that suppose the same IP addresses, if I have to write for the broadcast, like class A, broadcast 127.255.255.255, because all are ones, and if all are ones, they're 255. Similarly, class B 128.233.255.255. Similarly, class C 192.233.128.255. These are them. Now coming to one more part. Okay, class A, B, C are done. As we have done that, there are 5 classes. What about other classes? B class D. These are class D and E. These are basically reserved. I mean to say, this is for multicast address. What is multicasting? What is the difference between multicasting and broadcasting? Absolutely correct, Pushpanjali. Class B and class C as well. Okay, what is the difference between multicasting and broadcasting? Anyone? Yes, come on. Don't know. Okay. Broadcasting is if I'm sending to everyone, whosoever is in the network. Multicasting is if I'm sending to a group of people. Like suppose in the network there are 10 people, then if I'm sending to all, that is broadcasting. And if I'm sending to suppose 5 at a time, I'm making a group, multicast group, and sending to the group of the destination, that is basically multicasting. Like suppose I want to send it to all BTech students, that is multicasting. If I'm sending to whole university students, that is basically broadcasting. Am I clear with that? Yes, maybe in multicast message are sent to multiple people. Yes, absolutely correct. Okay, now coming to class B, these are basically reserved for future, class C, these are basically reserved for future use. Now coming to subnetting and supernetting. Okay, before that CIDR, sorry. So I'll come to that. So this was a simple, I'll say, class full addresses. Like where we have fixed number of bits, we have the prefixes where so that I can identify the class. We have fixed number of bits for host and networks. Okay, one more part. Now we studied that. Okay, network address and for broadcast address, these two addresses are reserved. So my host address, number of hosts is basically 2 power 24 minus 2 because 2 network addresses and broadcast addresses, they are there, that we are not counting in the number of hosts, they are reserved. So now I have the number of hosts of class A as 2 power 24 minus 2, class B is 2 power 16 minus 2, and 2 power 8 minus 2 as class A, because all zeros and all ones, they are gone to network address as well as the broadcast address. So now there was one condition which was given in class also. Like suppose you have 255 hosts in network. Which IPv4 address class will you use? How many class C is having hosts? Which class is valid? So basically, we know that how many hosts are in which how many classes. So which class is valid? So I'll go to class C and see how many hosts are there in class C. Can you tell me? Class C has 254 limit. Absolutely correct. As it's 2 power 8 minus 2, that is 256 minus 2. That is class C is having 254 host limit. So if I choose class C, I'll only have 254. I can't have 255 hosts in the network, so I have to go to class B. Now, what is the limitation if I'll go to class B? Can I say that? Okay, and can anyone tell me? Can I say that I have the whole space as 2 power 16 minus 2 as host addresses available in my class B, and using only 255 out of 2 power 16 minus 2, a huge address space is lost, is wasted. Does it make sense? Can anyone again tell what I'm trying to say, why I'm not choosing class C, and if I'm shifting to class B, what is the disadvantage? Can anyone tell to the class? Have you guys understood?
Lots of space is being wasted now. That's a drawback.
Yes. Absolutely correct. So basically, I'm having lots of space for host address. As I have in class B, like 2 octets for the network and 2 octets for the host. And host address is a 2 power 16 minus 2. This is for the host. And this address space, I'm only utilizing 255 out of this. So huge address space is wasted here. So that is why it's better to shift from, we should have something flexible, I can say. So rather than having, I can say, fixed number of bits, I should have something flexible so that the wastage of the space shouldn't be there. Can I say that?
Yes, ma'am.
So that is the reason we shifted from class full addresses to class less addressing. There was a drawback of the wastage of space, or if I'm choosing I want to have the lesser space, obviously I can't have by class C because that much of hosts are not possible. So how can I overcome this? I can overcome this. I like there shouldn't be a boundary. Rather than having a boundary, 8-bit, 16-bit, 32-bit, I'll say. Something in the middle should be used. That is the main part of this. Now, coming to this subnetting, supernetting, CIDR, that is classless addressing, let's try to understand it. Anyone, can you tell me what is subnetting, supernetting, CIDR, classless interdomain routing? Can anyone tell me?
Subnetting means it is to prevent the wastage of the larger network is divided into smaller networks.
Yes. So basically, I'll come to supernetting afterwards. Let's discuss about the subnetting. Basically, larger network is divided into the smaller network. If I have suppose this network, this is the host. So basically, this is divided into subnet number, I'll say. This is suppose the host number and the host number. Okay, let's see an example and then try to understand. Okay, and what is subnet mask? Subnet mask is number of bits. Don't worry if you're not getting, we'll do many examples of this. Previous year gate examples as well. The network address. Let's suppose I have taken from the presentation itself. This is subnet mask number 12. So what does it mean? How many network addresses are there? And how many host addresses are there?
12 network bits and 20 host bits.
Absolutely correct. 12 network bits and 20 host bits. As I have told you that subnet mask is number of bits in the network address. So which means 12 are there. And the host, I know that the total is 32. So 32 minus 12, that is 20 here. So 20 host bits. 12 network bits, can I write it as this 8 bits, basically 9, 10, 11, 12. These are the network bits, and then in binary, can I write this? And these are the host bit. This is the subnet mask, the network, the subnet mask. Let's see in more detail. Don't worry if you're not getting. I'll come up with many examples here. So if I say this IP address, this is also taken from the presentation itself. Now, how many network bits and how many host bits? Come on.
16 network bits and 16 host bits.
16.
Absolutely correct. 16, this was simple, 16 host bits and 16 network bits. Now, if I have to divide this into 3 subnets, is it possible by 2 bits? Like 2 bits are given to the subnet. I'll come to this also. Right. If I want to I have a network, I have to divide into 3 subnets, basically. So I need 3 bits, not. First of all, we'll see this. We need 3 bits for the subnets. How this subnet, suppose this is basically my IP address of the network. I need to divide into 3 subnets. So I gave the 3 bits to it. So suppose I'll tell you what does it mean. First of all, we have studied that what is subnet. We are dividing a large network into the smaller network. I'll write here. So, suppose I gave it 100, subnet 2 101, and subnet 3 110, which means out of 16 bits, I'm giving it to subnets. Now, how many hosts are you there? How many network bits are there? Yes, come on. How many network bits are there?
Subnet
Yes.
19.
19. How 19?
16 and then 3 extra from the hosts.
Yes. What about others? You guys understand how he has said 19? So we saw that, okay, there is an IP address this. We saw that, okay, this is an IP address. I'm doing the subnetting. Basically, I'm dividing my larger network into 3 subnetworks. And for that, I gave 3 bits to them. 3 bits means basically, this is okay, 203.110, and I have suppose here the 3 bits are given here. Again, the 3 bits from this, I'll say from the other part is it is basically 16, which means this is basically the network address, and 3 bits extra are given for the subnetting, which means 16 plus 3, that is 19. And how many hosts are remaining here now? 32 minus 19, can I say that? What does it mean? Like for the subnetting, to create a subnet, we have to take certain number of bits from the host. So we took 3 to distinguish the subnets, we took 3 bits. Now the question arises, why not 2 bits? Yes, can anyone tell me? Like to distinguish these subnets, why we are taking these 3 bits, 1000, 110, why not 2 bits? Overlap happens in 2 bits. Absolutely correct. Anyone else? So as he has written that overlap happens, let's see how this overlap happens. So suppose we have this 192.168 0.0. And as we discussed, okay, we should give 3 bits and not 2 bits. Let's suppose I am giving the 2 bits. Then what will happen? So to one subnet, if I give 0, 1, to other subnet, I give 0, 1, 0. What should be the third subnet? What should I give? If these are suppose all zeros. Yes, come on. What is the possibility? Like, what can I give to the third subnet? Like here I have given 1, 0, 0, 1, 0, 1. Sorry, 1. Sorry, 1, 0, 0, 1, 0, 1, 1, 1, 0. So here both 1, 1 and 1, 0 can overlap. How 1, 0 is overlapping? 0, 0 and 1, 1 are overlapping. Am I correct, Aman?
Oh yes, 1 1 0 1.
0, 0.
Yes, 0 0.
So basically, I can't give the this is the first subnet, fine. This is the second subnet, fine. If I give the third subnet 0, 0 or 1, 1, and if these are all 1, then what can be the case? That it will be treated as a broadcast address of the whole network. I'll say it will not be considered as a subnet. I can say how to identify that subnet. For the network, it will be considered as a broadcast address because all are ones. And if all are 0, it will be considered as the host address. As we know, what is the whole network address? What is network address? We saw that. Okay, what is network address? Let's go again. Network address is when all are zeros. And if I give it 0 here, 0, 0 here, as this other one, and these all are zeros, this will be considered as a network address for the main IP address. And if I give 1, 1, and by chance these are all 1, this will be considered as a broadcast address. And as he said, one of the students said that it can be overlapping. Now you got how it's overlapping, why we can't take 2 bits. What about others? Everyone has understood? Yes, come on. Come on, guys. Okay. So, basically, we can't use 2 bits because it can overlap with the network address or the broadcast address. So, if I have to I have to divide into 3 subnets. So, it's essential that minimum of 3 bits should be used. So, there is a very nice example there given in a presentation. I'll take the same example first. Suppose for CSC, I have 2000 hosts. For VGSON, we have 500 hosts. And for EE, we want 500 hosts. These are departments, and these are the hosts we want. And wait a second. The IP address 203.110.019. So how many network addresses are there? And how many host addresses are there? Yes. Come on. Simple. How many host addresses are there? So these are number of bits. Someone can I say okay? Yes, 19 network addresses and 13 host addresses. 2 power 13, or yes, you are correct only. So can I say 19 and 13? 13 bit, basically 19 bit host addresses. Total number of, you're correct, bits, basically 13 bits are for the host addresses and 19 bits are for the network addresses. And I have to create 3 subnets. From these 13-bit host addresses. And to address this 2000 host. How many bits are needed? Can I say 11? Because 2 power 11 is 2048. 2 power 10 is, I think, 1024. So can I say 11 bits are needed? And for addressing other 500 hosts, 9 bits are needed. So out of 13 hosts, I'm having, as you said, that we have 13-bit hosts. I'm taking 11 bits for CSC. Can I say only 2 bits are left for subnetting? And as we know that if we have 3, like I have to divide into 3 subnets, 2 bits are not like sufficient. Can I say that? Because we have to avoid all zeros and all ones for the broadcast as well as for the network addresses as well. First of all, you got the concept here, what I'm trying to say, and what is the solution? Can anyone tell me first of all what is this concept, what is the issue which is arising, and what can be one of the solution? Yes, come on. Yes.
The problem is like we only have 2 bits, but we are creating subnets. So that is
Why we have 2 bits?
because for just one department, the 2000 must complete all the bits. 11.
Absolutely correct. Now what is the solution?
I think the idea is to like probably mix the 500 or the smaller ones that we can mix.
Basically super netting.
Hmm.
So as we have now studied, okay, basically this was 2000 host, and for 2000 host we need 11 bits, and total we are having 13 bits for the host addresses. And if 11 bits it will be got for this, then only 2 bits will be left for the subnetting, and 2 bits are not sufficient for the subnetting. We have seen the problem for that. So that is why we took an additional router. We combined the 2 of the subnets. Basically VGSOM and of EE department, we combine them. So now I can say 10 bits for them and CSC 11 bits. Now if I want to see how it works, basically if I say network address, 203.110.0.0 0, 19. Uh, 16, 17, 18, 19, and these two. These are now I can use. Then if I have to divide into two subnets, can I use 2 bits now? I have combined this. Now I have to convert into I have to convert it to two subnets only, CSC and VGSOM plus EE. That is one subnet. I have combined them. So now can I use 2 bits? Come on. And how I have written this? No one asked me how I have written this 10 bits. I was hoping that I should write it like this and someone will ask me. Yes, come on.
Because
Come
of
Hmm.
1000 hosts, so 10
Yeah.
bits.
Because 500 plus 500, 1000 host and 1024, I'll say 2 power 10 is 1024, which are sufficient, so 10 bits. So now can I say that I have two subnets, CSC and the other is VGSOM plus EE, and then for them it's okay to use 2 bits because one I can one of them I can have it like 0 1 and the other one I can have it 1 0, so it will not create a problem for me, because the problem is if I'll use 0 0 or I'll use 1 1, because 0 0 if I'll use, then if all others are 0, it can be confused with the network address, and if all are ones, it can be, this one can be confused with the broadcast address. So it's okay to use 0 0 and 0 1. So one of them I can give it as 1 0 and other one I can give it as 0 1. So is it fine? Is the problem clear? The solution is cleared? Yes, come on. Okay. So the solution is cleared. We can basically, as one of you also told, that we can combine them. That is what we have done. We have combined them and then we have given 2 bits. And then again, inside that, okay, if I reach this if I reach this VGSOM plus EE, then I have to again identify that whether it's VGSOM network or whether it's EE network. So for that again, now suppose, yes,
కింద వస్తుంది నేను బట్టలు వేసుకుని పైన పైకి రాదు పైకి అంటే ఇక్కడ వస్తుంది ఇక్కడ మూలకు వస్తుంది
again I'll say, if I want to, now I am in the VGSOM plus EE network. Okay, I got to know that it is VGSOM plus EE network, identified that, but again for VGSOM and EE network, I have to identify within that whether it's VGSOM or whether it's EE network. So for that, here 0 triple 0, suppose this 0, I'll say this 0 1, suppose it was given to VGSOM plus EE network. So this 0 1 is given to VGSOM plus EE network. Again, I have to identify that it's VGSOM or EE network. Again, I'm giving this 2 bits. Suppose I'm giving this 1 0 for VGSOM. This was to identify whether it's CSC network or VGSOM plus EE network. Now I have to identify whether it's VGSOM or whether it's EE network. Does it make sense? Yes, is it clear? Come on. If it's not clear, I'll repeat it again. Clear. What about others? So we have done a basic thing only, like we have first divided into VGSOM and we have combined this VGSOM and EE network, and we have distinguished that VGSOM and EE network with the CSC part, and then again in the VGSOM and EE we have to again identify. Again we have given these 2 bits to the for the identification of that. So we saw that, okay, I think I have not written earlier. This was these were the number of networks. Now, can someone write that? What will be what uh, like in place of 19? What we have to write? In VGSOM and EE network and in CSC network. Come on. Yes, come on. How many network bits? 2 are given there. So 19 plus 2, that is 21. Can I say? And when I have to identify VGSOM plus EE, again 2 are given. Can I say 21 plus 2, that is 23? Is it clear? Why it's sounding like I am only speaking, you guys are not getting? Please, someone can unmute and can tell me whether it's clear. Am I audible in first place? Is it clear? Or should I repeat again? If I'm audible, can you tell me yes or no? So I hope so it's clear. It was the same thing which we have done, the network addresses, how we are basically giving to the subnetting part. Now comes instead of this giving up, instead of doing this subnetting and supernetting, I'll not go in detail. We can also do the variable length subnetting. Can someone tell me in short what is variable length subnetting? Yes, come on. Okay, I'll come to it afterwards. First, let's solve these problems. Let us take it as a homework problem. What is variable length subnetting? And I want you guys should read about it. Okay. Let's see the numerical question. I'll write here in the chat either. I'll start from very simple question. Can someone tell me what is the question? Read this question and then tell me how to solve it. Host in the class C network has been assigned an IP address. This find the number of addresses in the block, first address and the last address. Simple. Class C network, how many bits? For how many are for the network? How many are for the host? What is the first address? What is the last address? Okay, let's see the answers. 24 and 8, network and host respectively. So how many number of addresses? Can I say 2 power 8 minus 2? And first address 192.168.17.0. And the last address 192.168.17.255. And number of addresses 2 power 8 minus 2, that is 256 minus 2, that is 254 usable addresses. Is it correct? Should we proceed to the next question? It was very simple. Now let's go to the subnetting thing. Subnet IP address 216.21.5.0 into 30 hosts in each subnet. So we know that we went to classless addresses because of the wastage of the IP address. But here what they are saying is like we have to subnet this IP address. And this is obviously, first of all, we have to see which is the class. What is the class? Class A, B or C? Can you tell me? Which class it is? Class C. Absolutely correct. What is the default subnet mask of class C? Default subnet mask of class C is 255.255.255.0. You got it? Are you getting it or it is going above your head? Am I audible? Wait a second. I'm connecting from computer as well. Wait a second. Okay, our total number of subnets 8, 254 divided by 30. Let's see. Wait. Was I like I'll show you one. Wait a second. Actually, my Wi-Fi stopped working. I don't know why. I have connected to the hotspot. I don't know for how long. So where were we? The subnet IP addresses 216.21.5.0 into 30 hosts in each subnet. So what is the subnet mask? You got to know how 255.255.0. Is it clear? This part is clear. What is subnet mask? Like just 111 for all the network address, network part, and then 0. If I convert, the second thing is how I have to calculate. I'll give you the other question to solve. Okay. I have to convert it to binary. Okay. That means 8 ones. Again 8 ones. Again 8 ones. And then 8 zeros. This is basically the binary equivalent of my subnet mask. Now what they are saying is the number of hosts is 30. The number of hosts is 30, which means how many bits are required for the 30 hosts? Yes, can anyone tell me how many number of bits are required for the 30 hosts? 5 number of bits are required for the 30 hosts. Absolutely correct. Which means I have to basically reserve these 5 bits. What I have to do now? I have to reserve these 5 bits from right to left, which means 1, 2, 3. This is fine. This octet is also fine. This is also fine. Now these 5 bits, 1, 2, 3, 4, 5 from right to left, I have to reserve. These are all zeros and others are 1. This is basically how I'll divide into 30 hosts. Basically 5 bits were used, octet number 4, because these 3 are for the network, and now 30 hosts are there. This is how I convert it. And now if I have to write it in decimal, this is 255, this is 255, this is 255. This is basically 224. And if I have to write how basically, and one more thing, this is 5 bits and 2 power 5, or I can say is 32. How I have to write these 30 subnets? How 30 subnets? It was 216 dot. Maybe I'm rushing. Don't worry. Now just add 30, 32 basically. Now 31 only because 0 is there. Then the next subnet is the next, and so on. This is how 30 subnets are basically. Does it make sense? We'll go to the next question. Again, we'll do it and then we'll see if you guys will get it. If you'll not, again, I'll make you try this same type of question. Subnet 196.10.20.0 into 52 hosts. Subnet. Can you do this? First of all, write the class, which class it is, subnet mask, then how many bits are needed, and then reserve those number of zeros, and then write the range. And tell me the answer. You'll able to do it, or I should solve it for you? Do you guys get it? Okay, 5 minutes. Yes, yes. So should I wait? What about others? So I'm waiting for 5 minutes. Yes. Okay, let's discuss it step by step. Can someone tell me which class it is, first of all? Can you write it? Okay, so class C. Yes, absolutely correct. Okay, 255.255.255 dot, is it 92? Are you sure?
192.
192, yes. Can you tell everyone how you have solved this?
So 52 hosts, it means 6 bits, and so we
Yes.
reserve from RHS, and that link 24 plus 2, 26 bits for the net mask.
Yes, absolutely correct. So it was simple one only. I'll not solve it. As he have said, what we have done, like 52 means 6 bits, and 6 bits were reserved from right hand side, the zeros. So that is how he got this 192. Now coming to another, this is now GATE previous year question. An organization has class B network and wishes to form subnet for 64 departments. So what subnet mask would be? Now it is based on network requirement, not the host requirement. I'll solve it for you guys. Then you can like solve the other question similar to this. So basically, we know that, okay, now it's class B. Can anyone tell me what is a subnet mask? Can I say 255.255.0.0 as it is class B given to me? While now the next task is I have to convert to binary. 8 ones, again 8 ones, 8 zeros, and 8 zeros. Now 64 subnets, which means how many number of bits? 64 departments. Basically, this is a network wishes to form subnet for 64 departments, which means 64 network. Now I want number of bits for the networks. So how many number of bits? 64 means how many number of bits? 6, because 2 power 6 is 64. So 6 number of bits. Now, when I was having host specifically, like I was saying host 1, what was I doing? I was like having from right to left and reserving those number of zeros. Now, if I have to work for the network part is I have to work from left to right And now those number of ones. So how many number of ones? 6 number of ones. So here 1, 2, 3, 4, 5, 6 number of ones, then all zeros. So basically 255.255.252.0, the new subnet mask. Is it clear? Is it clear? Yes, come on.
One question, ma'am. So
Yes, yes. Yes, yes.
we are dividing the subnet into for 64 departments. So this will be like a kind of a main router which will route to each of the department.
Main router, which will, yes.
Okay.
Basically, here we are dividing into networks. Not a network is having 64 hosts. Are you getting my point? We are having here like the network division. Are you getting it?
Can you like draw rough diagrams, like how would it look? So just one or two departments, just overview kind of.
I think we have done this overview thing. Huh? Wait a second. What was this? Can you tell me?
This was for so for first for the organization, then for different departments.
Departments. So basically, an organization, like different departments, I have divided into. Now, what is the other thing? Now, what we are trying to do here in this question?
Okay, so this address that we, so basically we are creating a net mask for the let Tirupati. Okay.
And then dividing into different departments, basically. Now, maybe I'll in the next class I'll have some diagrammatically representation of all these so that you can get more idea about this. Okay. If class B network, this is also a great question only on internet. Wait a second. Has subnet mask of 255.255.248.0. What is maximum number of hosts per subnet? Yes. This is simple one only. Come on. Or I'll do one thing. I'll write this question. One more question. This is So these are, let's take it as homework question only. I'll just give you an idea. If class B network on internet has subnet mask of this, what is the maximum number of hosts? Again, you can convert into binary and then simply you can calculate that. How many number of hosts basically? This is the simple question only. The next is address of class B host is to split into subnet with 6-bit subnet number. Now again, it's basically network requirement based on network requirement. Again, 6-bit network basically. Again, 6-bit means like you'll have 6 ones from left to right, and then you can check how many number of hosts and subnets in each network. Is it clear? Subnets already it's given 6, so how many? Is it clear? Okay, someone has written in the chat. Let's see. 2 power 11 minus 2 hosts. 2046. Yes, 2 power 11 minus 2 hosts, absolutely correct. And now can you solve this question? Narendra, it's -2 also, because we have seen that, okay, -2 are there because for network address and broadcast address that are reserved. So that's why it's not 2 power 11. Yes, 11. Is it clear, Narendra? Okay. Now can you solve this question? Okay, net bits 22, host bits 10, network bits 22. Okay, network bits 22, okay. And host bits 10, okay. 16 plus 6. Hosts are 1022, that's fine. How many maximum number of subnets? Not whole network, only subnets. That's simple, only 2 power 6. Is it clear? Yes, 16 plus 6, maximum number of subnets. Yes. So I hope so these questions you all have done. If anyone is having doubt, you can ask. Okay, last time I was asking you again and again of the socket programming part, that who were there in the last lecture, because I have given some like we were discussing something like why there is a loop and all. But as I think that all the new students are there, I can't discuss this. Maybe this is my request. Look at that video of socket programming, how we have done that. We have done all the program of TCP server, TCP client, UDP server, and UDP client. And then I'll tell you in the short, the doubts which were there. And as I gave a homework problem, or I said that, okay, we'll discuss in the next class about this. So maybe in the next class, we'll see how the loop and all, they were there, and concurrent servers as well, we can see. I was in the hope that we'll complete this addressing and then we'll come to the QoS also, but I think it took a lot of time. Any doubts in today's class? I hope so. The class was interesting. Any feedback? What about others? Okay. Yes, ma'am, we need to solve more numericals. Yes, we need to solve more numericals, but the thing is, we don't have time. Like I already asked you in the class that whether I can either bring numericals only and not like make you understand the concept. Because if I'm solving only the numericals, then you all are saying that okay, we need to understand the concept as well. So that's why I'm trying to have both numericals as well as the conceptual understanding also. But the part is that we are lagging behind a lot. Like I think we are in week 6 or 7th lecture, and now week 9 is going on. So that is the main issue, and I don't know how we'll complete it. I was in the hope that we'll complete QS also as well in today's class, but it takes time for everything.
Ma'am, can you take extra mini
I
class?
will take extra class at the end, but one class only they can allot me, not more than one. That is a choice for each TA that we can take, but only one class will be allotted to me.
Yeah.
That is the main issue. And if I think about time, actually I have a small baby, so it's not possible for me to give more than 2 hours. I hope so in the next lecture we'll try to cover. And one more thing, keep on reading the things and all. And if you have doubt, write in the YouTube channel comments also. If you have doubt about the next lecture also, or mail me at least. Because you guys have to solve the assignment problem as well. Okay, thank you class. Thank you so much. We'll meet on next Tuesday.